Good morning, lovelies. Today I am going to make this video for you since I'm out. Just more of what we were doing yesterday with maybe a slight variation in instructions. So we just want to make sure we're reading the instructions carefully as we go through these. But this problem is a continuation of exactly what we were doing yesterday. So the first thing I notice is that actually the first thing I notice is this business here should look pretty familiar to you. This should look like one of your trig identities because it is. So what this can be rewritten as is tangent alpha times cosecant squared alpha, because this highlighted portion here is equal to cosecant squared alpha. And again, you're going to want to have your that first sheet that we did with your trig identities out in front of you until you get really comfortable with this stuff so that you know that. And then we have cotangent alpha. Next step is just like it was yesterday. We want to convert all of these into terms of sine and cosine. So tangent we're going to rewrite as sine alpha over cosine alpha, because that's what tangent is equal to. And cosecant squared theta we can rewrite as 1 over, and it's being multiplied, so that's why I put the multiplication, 1 over sine squared alpha. And then this is all being divided by, and again, because I don't like that double line business, I'm going to put the division symbol. We are dividing by cotangent, which is a ratio of cosine alpha over sine alpha. Okay, so simplifying what we have on the left over here, we would have sine alpha over cosine alpha, sine squared alpha. And I'm just going to leave that for now because when I do my invert and multiply, I'm going to take this one, switch it around and multiply, then I'm going to start to see what I can cancel out. Okay, so now when I multiply, I'm going to have sine squared alpha on the top, and I'm going to have sine squared alpha on the bottom, so those things are going to cancel out because I have a sine here and a sine here, which is going to cancel with both the sines there. So this leaves me with 1 over cosine squared alpha, and that's not getting any simpler, and it's in terms of cosine. So that's exactly what we needed to do on that problem. Okay, now notice the directions are changing a little bit here. We are going to write this just as a single trig ratio. So in the end, you should have a singular trig ratio. This could be something other than sine or cosine. So this could be any of your 6 trig functions, but you are looking to have something like sine x or cosine theta or secant theta at the end of this. So that's what they mean by single trig ratio. All right, so strategy is going to be the same as it was when we did this yesterday. We're going to start by rewriting these things in terms of sine and cosine. So secant is 1 over cosine theta. Cosecant is 1 over sine theta, and these are being multiplied. And tangent is a ratio, we're subtracting tangent, the ratio of sine theta over cosine theta. All right, so on the left, simplifying this, I get 1 over cosine theta sine theta minus sine theta over cosine theta. Well, in order to combine these, I need a common denominator, which means this guy over here needs a sine theta on the bottom. So I'm going to multiply by sine theta over sine theta, because that's just 1. I can multiply anything I want by 1 and keep it the same, but now I'm going to have a common denominator, which is what I want. So now I have 1 over cos theta sine theta minus sine squared theta on the top over cos theta sine theta, which is great because now I have a common denominator, so I can make the top 1 minus sine squared theta over cos theta sine theta, which is great. 1 minus sine squared theta should be making you think about your identities because it is a slight variation of our most basic Pythagorean identity, and that is going to be equal to cosine squared theta. So the top's going to become cosine squared theta because that's what 1 minus sine squared theta equals. Again, have your identity sheet in front of you, over cosine theta sine theta. Well, cosine and cosine are going to cancel out. So one cosine from the top is going to go away, leaving me with one left on the top and no cosine at the bottom. So what I'm left with is cosine theta over sine theta. But we want this to be a singular trig statement, so we're going to turn that into cotangent theta. And that is our answer. All right, we're going to do the same thing on the next one. Again, shooting for a single trig function here. So we're going to rewrite secant as 1 over cosine x this time. We're going to rewrite cosecant as 1 over sine x. We are going to divide by 1 plus sine x over cosine x. Well, now I have multiple addition things happening here and no common denominators, so I'm going to have to deal with both of these. On the left-hand side, we're going to multiply this one by sine theta over sine theta. And on this one, we're going to multiply by cosine theta over cosine theta so that I get a common denominator. And then over on our second, in the division portion over here, I'm also going to turn this 1 into cosine theta, or x as the case may be, over cosine x so that I have a common denominator there. Okay, so now on the left-hand side, we have sine x. These all should be x's, not thetas. X, 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 x. Okay, over sine x cosine x plus cosine x over sine x cosine x divided by cosine x over cosine x plus sine x over cosine x. Okay, so now that we have common denominators, we can combine these. So on the top of the left-hand side, we have sine x plus cosine x all over sine x cosine x divided by cosine x plus sine x all over cosine x. Okay, so now we're going to invert the second one and multiply. So we have sine x plus cosine x over sine x cos x times cosine x over cosine x plus sine x. Well, this is highly convenient because you'll notice that we have sine x plus cosine x and cosine x plus sine x. And remember that order does not matter when we are adding. So these two cancel out. They are exactly the same. And then I also have a cosine x being divided by a cosine x. So that's going to cancel out. And I get 1 over sine x. But we want a singular trig function. So we want to turn this into the inverse of sine, which is, cosecant. Cosecant x is our singular trig function here.